Hi, welcome to Learn and Flutter. And today we're going to wrap up our look at the block pattern. Now, we have finished implementing the block pattern in the last video, part 4. The thing I want to cover in this video are some best practices and recommendation for how to use streams. More specifically, we want to look at how a stream should behave when there are no listeners, or if listeners are paused. If listeners ask that, hey, hold on a little bit, I don't want to receive any messages now, or a listener cancel their subscription and don't want to receive any more messages. What happened in those situations? So let's get started. So again, we're still working with block pattern, and we had 4 parts so far. And so I'd like to start with part 5. And so let's make a directory for that. And as usual, I will like to start with the last example we've written. So let's do that too. And so we'll go to part 4, get example 5, and we'll copy that to our part 5 directory and call it example 1. Okay, so now if we jump over to our Visual Studio Code editor, you see this is a newly created directory. And there is our example 1, and this is the code that we ended with. Here's the problem. Like I said, we want to make a well-behaved stream. How do I know that that's something we should do? Well, here we create the broadcast stream, and if you put your mouse over it, you'll see. So here are the parameters for the broadcast stream, and you can see the 3 parameters: on listen, on cancel, and sync. For us, the 2 we're going to be focused on today are on listen and on cancel. On listen is a callback that you can pass to the broadcast stream to say, when the first subscription occurs on my screen, let me know that somebody is ready to listen. Now, this on listen is not going to be called for every subscription, just the first one. The first time you want to know when somebody subscribed and that you have at least 1 listener, that's when you can say, well, now that I know I have subscribers who are interested in what I have to say or what I'm going to produce on my stream, now I can start producing data. If you don't have any subscribers, you shouldn't produce any data. And on cancel is going to be called when the last subscriber unsubscribe or cancels from your stream. And again, that lets you know that there are no more subscribers, so I shouldn't use CPU or whatever, do any work in producing any data because there's no one listening. So we're going to use those 2 things. And if you read the documentation here, and so we covered this already about why we use a broadcast stream, but if we look here, it says a stream should be inert, which means it doesn't have any effect essentially until its subscribers start listening on it, using the on-listen callback to start producing events, which is exactly what we just said. Stream should not leak resources like WebSocket when no user ever listens to them. And what it's talking about here is, for example, if every time something happened and your stream would emit a event that somehow creates some sort of resource and there's no one listening there to accept it and possibly clean it up, then you could leak resources. At the worst, you're probably just going to be doing work unnecessarily. Even if, let's assume that all the resources will be tracked and cleaned up properly, you'll be creating resources that just simply have to be cleaned up anyway. So you're making work for the garbage collector. So we do not want to do any work unless someone is listening. And so it goes on to tell you a few more things. And it says broadcast stream do not buffer events when there are no listeners, which means that if there are no listener, you emit an event, well, there's no one to collect it. It doesn't buffer it up until users subscribe and then they get the event. They also talk about what happened when subscriptions are canceled or paused. But here's the interesting thing about pausing. Each listener's subscription is handled independently. And if one pauses, only that pausing listener is affected. A pausing listener will buffer event internally until unpause or cancel. And we will demonstrate it. We'll see as though we'll have a subscription to the stream, we'll pause it, and we'll see those events are going to be buffered for us. Now, I don't know exactly how much it can buffer and so on, but at least we're going to be able to demonstrate that that is the case. Okay, we're not going to be worried with the sync, but you can certainly read how sync works. So enough talking, let's get to the code. So like we said, we want our stream to be well behaved. Now currently, when an event is added to our stream, we immediately put it in the state, and then we emit that event on our stream, but we do not know if anyone is listening. Now, if we look at our example code, what we do is we create our block and we immediately add listeners or subscription or subscribe to that stream. And that's why when we start adding events to our stream, or to our block rather, then we get those notifications. But what if we were to do something like this? Now we've created our block, we've added items to it, and what is going to happen is it's going to try and emit an event, but we do not have a subscription yet. Now if we run this code, it's not going to blow up. Remember, all it's saying, good practice said, is that the stream should be inert or shouldn't try to emit an event if no one is listening. And at this point, no one is listening, so it shouldn't try to emit an event. Now let's run this code and see. So if we run it and we go back here, we can see we get item number 2, which is okay because we weren't subscribed yet when the first event occurred, which was this milk. So it makes sense that we should start getting events from the second item, third, fourth, and then of course the cleanup and so on. All right, or the remove. Okay, so our code didn't blow up, but this is not a well-designed stream according to the documentation. So one easy way to address this is for us to simply have a variable that tells us when our stream is enabled. I'll say enable or active if you like. So by default, I'll have this variable and it's going to be set to false to set out our stream upon construction is not enabled, which means it will not be producing any events. It's inert. Now, what is the underscore? In Dart, underscore usually means that this member is private. So we should make our other properties of this class private also. Okay, so that's just some good programming practice to use underscore for properties that you don't intend to export from the outside. So that's all that is. So okay, so now we have our variable. How do we use it? Well, we said that we don't want to emit an event unless the stream their listeners, so our subscribers. So we should just simply put an if statement here. That seems pretty straightforward enough. And so we can still add things to our block, as in this example. We can still add things to our block, but our stream would not try to emit an event because it's not enabled at this time. So how do we trigger enabling of our stream? Well, I already showed you that we can pass a callback when we have our for subscription, which is our onListen callback. So instead of adding a function literal here, I'll instead just create 2 simple functions. I'll make them private also. And so now we have the 2 callbacks that we can use here. And so we say onListen, for example, doesn't matter the order, is going to be called by this callback. And so we don't want to call the function, but rather give it the callback on cancel and on cancel. And so we don't want to actually make the function call. So we just assign the callbacks. So that's correct now. And so we didn't see any difference before, so we shouldn't expect to see any difference now. The only thing is that we know that our stream is well behaved. It is inert when there are no listeners. And so we can put some debug messages in here to see when things happen. So, all right. So we have a few debug messages to let us see what is going on. And so let's clean up and we'll open this up a bit and we'll run our code. And so you can see we're adding event to state, and then we're enabling the stream, adding event to state, and now we're emitting events. And the way we know that how this is working is because we do not see an emit event for the first add when we add something to the state. And that occurred because the first subscriber is the one that caused us to enable the stream. The second subscriber, because the stream is already enabled, did not cause us to call that on listen function again. All right, so I think that's pretty straightforward. I don't want to belabor the point. Hopefully you get it. Okay, so let's clean this up and let's move on to our second example. So as you will, copy this, paste it. And so let's talk now about canceling subscriptions. And so to do that, what we need to do is save the subscription. Now, when we subscribe by calling the listen method, if you notice, return a value, which is a stream subscription. And so we can use that stream subscription to cancel our subscription or pause our subscription to the stream. So let's do that. So I'll do sub 0 to just mean subscription. Sub 1, again, the second subscription that we get back as a result of listening. And so right now we're not using these variables, but what might we want to do? Well, after we have listened we subscribe, maybe subscription 1 wants to cancel its subscription after listening for the first message. So, and there it goes, cancel its subscription. And maybe the second subscription wants to cancel after these messages. And so there it goes. And what we would expect is to have this subscription want, number of items to be printed out for this after this first event. Well, this is really our second event, but you get, what I mean when I say after the first event. Well, the event that occurs after it subscribe, we should expect this subscriber to print out 3 messages. This one to print out 1. And then after that, they don't see any of these other 2 messages. All right, so let's run and see what we get. And if we look, something is wrong, right? What is going on? We do not get any messages. None of our subscribers got any of these messages. These messages are still correct. We add something to the state, then we enable the state because we had subscribers who register. We add events, we emitted those events, emitted them, and so on. And now look at this, we're disabling the stream. That's because we had the last subscriber cancel, so there's no reason for us to emit anything. And then we had 2 more events, which is the remove item and remove all. So this looks fine, except that we do not see our subscriptions or subscribers printing out and their function getting called. So what is happening here, if you remember, is that when we do a listen, whether that's listen to a stream or the then call on a future, what we're doing is creating a function that will be added to the task queue. If you remember, we had that event queue. We cover when the beginning of this, we cover how Dart has this event queue. And first it calls your main function. And after your main function runs, anything that's added to that event queue by futures or streams, they get placed on that queue and they run after your main program exit. One other thing you can do is, in addition to the task queue, you have the micro task queue, and you can insert something in the micro task queue that get evaluated before. So if this doesn't make sense, go back and watch that earlier video that cover how Dart handles the video on futures. Okay, so what is happening is when we say, so this, let's clear this out. I'll close this actually. So what is happening is, this is happening during the execution of main. We're adding something to our block. We subscribe, which then puts this on the event queue to be run after main run, because as a future time when there's event, then we want this code to run. We don't know when this is going to happen, but it's not going to happen now. So this is placed on the event queue for later, after main. This is also placed on the event queue after main. Then we added some events to those to our block, but this code will, these 2 listeners will not get to run, because remember, they're going to be evaluated after main. We cannot go back and evaluate them now that we're in the main function. Dart is a single threaded application. So once we start this thread and come through and start executing main, we cannot go back and then pull something off of that queue that's added to the queue that runs and get checked after main runs. And so when we do cancel, then this go and remove this subscription or this listener from that queue. And similarly, even though these things are going to be inserted into our block and eventually emitted as events, this also removed the second subscription from the event queue. So think of these cancel. First, the then function put these callbacks on the event queue, and the cancel remove them from the event queue. And so then we generate some more events, and so main ends. How do we know this? If we put a printout here, and now we rerun our code, we can see main ending after all these events have been sent, after disabling the stream. Okay, and so let's clean up. Because we've canceled our subscription, when main ends and now we go look to see what work we have to do, well, there's nothing there to do because we've canceled. Now, you may think, well, this doesn't sort of make sense. How can I use cancel then? Well, let's use a future, just like we just said that using listen or using a future puts a task on the queue to be run after main. Why don't we plan for our cancellation to occur after main runs? And so how do we do that? Let's copy the code, paste it back. That's not what I want, so I'll delete that because I'm lazy. I'll try pasting it again. Do paste. We should have exercise 3. So let's close these guys and let's look at exercise 3. So the problem is that we're canceling in main, and therefore by the time main run, we don't have any callbacks on the event queue to run. So what we want is cancellation to happen after our main function run. So let's change our example a little bit. I'll simply clear this out and just write some simple Dart code. And so for example, I'll remove this and we'll say that what we have is something that emits time, the current time. So we'll call this our timer block. Right? Timer block emits time. So therefore, what we have is our stream just simply emit the current date time. That's it. All right. And so stream controller emits current date and time. So we still need to be able to know when the stream is enabled and when it's not enabled. We don't need to keep state because since we're emitting the current time, well, whenever it's time for us to emit something, we'll just do that. We'll just create an object and emit it. That's it. Nothing else. Now, when it comes to getting the stream, we can do that. We don't need to worry about adding an event in this way like we were thinking before. We don't have events to add. So this also, we can get rid of this. We don't have actually need to take a parameter. And we can also get rid of this because we're not keeping state. And if we're enable, of course, and in order to emit the current time, we simply do that and time that now. So there we go. That looks good. Now, what does our function look like then? So we're not going to be doing this. We should call this, let's for example, listener 1 and print out the time that we got. So on data. I know I'm mixing my quotes here. So 2 listeners that simply print out the time that they got, but we know which listener we're dealing with because we're going to use cancellation and so on. So we can get rid of these guys because this is not how we add things to our stream. All right, and this guy. Okay, so our example is very much simplified. Let's just look at it again. We have a timer block. we subscribe, we had 2 subscribers, and later on we cancel. We'll get back to the cancellation, but here's the thing. How do we generate an event? Right now we have this on function, but it's not being called. So what we want is to be able to periodically just spit out a new time. So we can do this by having, let's say we have a function that calls start. So what start does is it starts running or calling this function. So we can put a for loop here, for example, something like that, and then say for true, which would just run forever. I want you to just call on. Now this doesn't quite work, but you can imagine if this was a while loop, it just keep doing this and maybe just keep spitting out event, but we don't want that. What we want is, in this example, to spit out an event every 1 second. So we can use a future that while, for example. And what this does is, if you read this, it performs an operation repeatedly until it returns false. So long as we are enabled, we should spit out an event. So we can use this and say this is our action, and our action is simply a function that call on to spit out an event. That's what we're going to do. And what we want though is, if remember, this runs repeatedly so long as there's something, it returns true. And if you want it to stop, you return false. So we can return this. And the first time we call this, when our stream is enabled, for example, we should call this. So once we're enabling the stream, we should call start, right? So our first subscription should call start. And well, before it calls start, we should absolutely enable our stream, because otherwise that wouldn't work. We enable our stream, call start, and then start would sit in this do while loop, which is future do while loop, and keep printing out events. But we don't want the events to come out that fast. It's going to be very fast. It's just in a tight loop here. What we really want is to delay a little bit, wait a second. So spit out an event, go do it again. Spit out one event, do it again. So what we want is actually a future that delay. And delay takes a duration, and duration of seconds. And so we're going to do this every second. And here we want to do this, a callback. This is our, so let's do this, future that delay. And so every time, every second, after a second, we want to call on, and then of course return a value. So we return the current value. Okay, so let me go over this so we are all on the same page. When we start up, or when a user creates a new timer block, by default it will be inert. Now, since we're the one generating event, we don't have to worry about spitting out event without any subscribers. But once we have a subscriber, we will set this to enable and call this start function. If all our subscribers are removed, we'll of course set this to false. What happens once we start running? So remember, this is going to happen if you have some subscribe. If you have a user subscribe, then they unsubscribe, you disable, then they resubscribe or not a subscriber. So every time go from no subscriber to having at least one subscriber, this is going to be called. And so now we start. What happens when we start? Once we start, we're going to sit in this loop. We're going to call this function that sit in this future that do while loop. Or future that do while loop now, because it's a future, it's essentially adding this function callback to the event queue for us to consume after main exit. this will run repeatedly so long as a true value is returned. So how does a true value get returned? Well, this is a future. Well, and why we run a future is because a future delay is because we don't want to spit out, we want to delay how often, we want to control how often we spit out message. And for us, we want to do it every second. If we didn't do this if we remove this future and just simply put this, call our on function, which emits an event and then returns true, we'll be sitting in this very, very tight loop, and we'll be spinning out event very, very quickly. So by doing a future that puts this code on the event queue to say, call this after 1 second later, emit an event, and then that future is finished. But because we're in a while loop and we return true, it will schedule another future. And so we'll keep scheduling future until we don't have any more subscription. Hopefully that makes sense. Seems pretty straightforward, but remember, you can jump and take a look at this code right now, study it, make sure you understand it. I think it's simple, so I'm not going to go over it and waste time. So let's move on. So now let's just simply run it. So here we are. Oh, before we run it, we subscribe. And again, we don't want to cancel immediately. We want to cancel in the future. So imagine that our timer block is emitting events every second. Well, when do we want, well, before, let's run it and see. Let's just run it without doing any subscription. And let's see that that works. And so we'll ignore the warning from Dart for now. And what do we have? Oh, Boolean expression, assert null. Where is this coming from? Do well. Line 15. Let's see. Saying we have so here is returning so return a Boolean value. Oh, so because, well, our future is returning a Boolean value, but we don't actually return a value from our do while. So remember, our do not while needs a return value. So we're going to return whatever the future returns here, which is true. So that was the problem. So let's clean up again, run. Does that make sense? Well, in other words, let me simplify this and say this. We need to do some work, then return true, or return a Boolean. Whether that true means that call me again, do some more work, or exit this do while. And so we need a return value from our work function. And we did not have that before. So by returning the result of this future, that is our return value for this do while. What is the return value of this future? It's this value. Because we return a value from this delay function, this future is returning a Boolean value. And therefore, when we return this future to within our work function here, within this do while, then this becomes the value that is resolved. All right, so run the code. And we can see main is ended, and we can see events. And notice every time we emit an event, both of our listeners get called. All right, so this is going to continue on every second. This is 34, 742, 34, 742, 35. So every second we're emitting an event. Why? Because in our do while function future, we always put another future to be called 1 second later. Okay, so this is going to run forever. So let's stop it. And so this shows that our program exited. And let's clean up, close this. What we want to be able to do is cancel subscription. So let's say that we run a future. After 3 seconds, it cancels subscription. So here we go. We say 3 seconds after main ends, essentially, something like that. I want you to call cancel on subscription 0. And we'll do something similar with subscription 1, except I'll copy this code because my editor is misbehaving, and so it's giving me a lot of trouble to type this. So instead of 3 seconds, I'll do this 6 seconds later. Okay, let's do 7 seconds, doesn't matter. And so what should we expect? We should see some messages for both of our listeners. then we'll see no messages for the first listener, because it's essentially goes, I'm done. After 3 seconds, I'm done. And then we should see messages continue for our second listener. And then after 7 seconds, it says, I'm done. And at that point, our program should end, because we should have cleaned up. We would have canceled our, because we have no more listeners, our on cancel function here will call, disable the stream, set this to false. Our do while function here, when it tries to call on, it will see that it's false. It will not emit an event to the stream. So that's correct behavior. And then because this value is now false, it would return false and not get called again. So it means this feature will go away. And so everything should clean up properly and we should see our program end. So let's run this and see. And so we end and notice we have a message. We have another message and notice what happened. Now we only only listener 2 is getting events because listener 1 cancel and the first subscriber cancel. And then notice we're disabling the screen. And even though we're adding event to the state, well, because we have already disabled the stream, that wouldn't matter. Our error this message is from, where is it? This message is from here. It says we're adding an event, but we've already disabled the stream. So we know that even though this is called, we did not emit an event, which you can see here. So there's proof that we have proper behavior. And then everything cleaned up, our program ends without us having to terminate it. Okay, so this demonstrates that cancellation work. Now let's demonstrate pausing. So I'll copy example 3 and paste it. And now this becomes example 4. And so let's clean up again and go here. Now I know this is probably a little bit slow for some people, but hopefully taking my time explaining it and showing you how the code evolve help those of us who sort of come to this thing and now learning it for the first time. So let's do cancellation. So for the cancellation, after 7 seconds, I want to cancel, pause my subscription. So let's do this. I'll actually, let's leave it this way. And I'll say this. I'll say after 3 seconds, I want to pause my subscription. Now remember from the documentation, what does it say about pausing? It says that each subscription is handled independently, right? Where is that? Each subscription is handled independently, and therefore, yes, each listener subscription is handled independently. And if one pauses it, only that pausing listener is affected. A pause listener will buffer event internally until unpause or cancel. So that means that for our subscriber 0 here, we're going to pause after 3 seconds. So first we're going to get some message and we're going to say, well, we're busy, we're tired, we don't want any more timer event. But remember, those are going to be buffered. So it's still going to get it. It's not going to miss out. It's just need a break. And so later on, after, I don't know, 10 seconds or something, well, we're going to resume our subscription. Notice how we can listen, get a subscription, and then that subscription we can call cancel, pause, or resume. Now, once we resume our subscription, we should be able to get all the messages that occurred after we were paused and until we resume. And then what we want to do is, because I don't want this program to run forever, I'll say after 13 seconds, I want to cancel, because at that point, this is going to be the only subscriber, because this subscriber would have canceled. Okay. Now, if you notice what's happening, if we look timeline wise, we'll see that this guy is going to pause after 3 seconds. Things are going to go until this guy cancel. Before, when we had this cancel, our program would have ended. But because we have a subscriber who's paused, remember that subscriber did not go away, it's just pause. So that means that we should not close up and go away, because we still have somebody who's listening. It's just that they're not actively listening. Does that make sense? So our program is still going to be running even with that one subscriber who's paused. And then once they resume, they're going to get the message that was buffered for them. and then they're going to listen to a few more messages real time, and then they're going to cancel. And at that point, we should expect our program to end. So let's run this and see. And again, if you're not getting this, definitely just play with it. Just change the numbers around and see what's happening. And you can see we got both listeners were there, and then we were generating events, but because we had a pause listener, nobody was getting called. Those events were queued up. So now our listener, when it resumed, it got all of those events that were queued up, and then it got some more events after it resumed, and then it canceled. So hopefully this demonstrates how cancellation and pausing and resuming work. I'm not going to waste any more of your time. I think this sort of covers it fairly okay. Of course, you might need some additional material and playing around with the example and so on. Take care. See you in the next video when we move on to some new topics. All right, bye.